So I'm going to intro our next speaker, who is named Dan Slimmon, by talking about a completely different talk that was awesome and that changed the way I think about ops. So I was at PuppetConf 2 years ago in 2012. Heard this talk by a guy named Jamie Wilkinson at Google. And it was called Better Living Through Statistics, How to Have Monitoring That Doesn't Suck. The video's online, highly recommend it. And what he did, he blew my mind, and I think basically everybody else's mind who attended his talk, by getting up there on stage, pulling data into R, and doing some R hacking live on stage with monitoring data. Really thinking about understanding what's actually happening here instead of just looking at some dumb graphs that go up and to the right or down and to the right. And maybe there's a spike and you don't know what's going on there. But really developing a deep understanding of what's happening and why it's happening. And Dan is going to talk about a similar idea, right? Thinking about why are things happening, how do we connect what we're doing with the data and with the theory behind the data to really understand DevOps in the context of Conway's law. So take it away, Dan.
Sweet. Okay, yeah, wow, there's my voice. Cool. Hi, everybody. This talk is called The Skeleton of DevOps, Conway's Law. It's not a spooky talk, don't worry. There's no skeletons in it. Boo! Okay. I swear that's the last skeleton. So I'm Dan Slimmon. These are all my social media thingies. I bet you can guess what my username will be if a new social media thingy happens. It's all right there. I work in ops at a company called Exosite here in Minneapolis. We are an Internet of Things company, and we have a platform for which devices can upload their data and do time series analysis, alerts, that kind of thing. We helped a company build a mousetrap that's internet connected, so really we'll just rub some internet on whatever you want. Before I was at Exosite, I worked at a company called Blue State Digital in Boston, and we were doing bulk email, web outreach, that kind of thing for nonprofit organizations, liberal politicians, et cetera, et cetera. So I've been doing a lot of ops, and I've had a chance to think about how we know what's going to work in DevOps. You know, DevOps has all these different pieces, and sometimes we have a success, sometimes we don't, but we don't really think about predicting some sort of model to predict whether something's going to work, right? So somebody in the chat room's like, hey, we should do chatops, because that worked for GitHub. And everybody's like, okay, yeah, sure, we'll do some chatops. And so you get everybody in the chat room, and everybody's doing deploys there, and doing their incident management there. And it turns out it's great. Everybody loves it. Like, you ride away on a DevOps luck dragon, and everything's wonderful, right? But sometimes it doesn't quite work like that, right? Sometimes somebody's like, well, we got all these crufty old bash scripts that set up all our servers, and maybe we should use Chef, right? Maybe we should translate all this stuff to Chef. And everybody's like, yeah, okay, Chef. I've heard of Chef. That sounds good. So you're like, yeah, we're going to Chef it up. We're going to put all the, package it all up into recipes and do all the Ruby things. And you're working on it. You're banging on it. Turns out you got a lot of bash scripts, and you're working through bugs. Maybe things aren't working quite as awesome, quite as fast as you would have liked. And a couple weeks later, maybe a couple months later, your boss is like, are we done? Did we do the DevOps thing? Did it pay off, right? And you're like, yeah, I think so. I guess, maybe not. And I think it's because you didn't make a prediction beforehand about what effect this new DevOps thing was going to have on your business. So I'm talking about theory today. And theory gets kind of a bad rap among doers like us. We hear, I have a theory about how this works. And we're like, oh, you can go up in your ivory tower with your thinking and your theories, and I'll be down here with my boots on the ground, getting elbow grease on my boots and wiping it off on a grindstone because I'm a doer, right? But I think theories are good. When I say theory, I mean a set of rules about a system that generates predictions about how that system is going to respond to stimuli. And a system can be anything. It can be anything that's composed of multiple interacting pieces. So it can be something tangible, like a clock or a human lung. It can be something a little less tangible, like a website or the infrastructure of a city. Those are a little bit more cerebral. And then it can be something completely cerebral, like a branch of mathematics. You can develop theories about any set of interacting pieces and figure out, try to figure out what that thing's going to do when you give it a new input, right? And experiments and theories are not opposed forces, right? They need each other. You need experiments because you need a way to test your theories, and you need theories because you need to know what's possible and what's maybe possible and what limits of possibility you should explore with your experiments. So I'm going to tell you a story about a very, very useful theory. Not just interesting, but useful, that had a lot of practical implications in the 20th century. So these are the hydrogen emission lines. And they are, so basically when you get a bunch of hydrogen in a jar and you run electric current across it, it starts to give off light. And it doesn't just give off white light in all the wavelengths of the spectrum. It gives off very specific wavelengths of light. So we have this, is that red? I'm colorblind. Is that over there? Okay, so we got this red over here, and then we got this blue, and we got a couple more violets over there, and nothing in between, right? We don't have green or yellow or any of that. We have these very specific wavelengths. And people could reproduce this in a lab for many, many years, but had no idea why this was the case. It just sort of wrote it down, right? And you could write down the numbers and try to find a formula into which those numbers fit, which is what Johannes Rydberg did in 1888. He was like, hey, I found this formula, and if you plug some integers into it, you get the hydrogen emission lines. And everybody's like, sweet. I don't know what that means, but sweet, right? Like for 25 years, atomic physics looked like this. It's like, yeah, that formula sure does work. Yep. Yep. Those are some numbers right there. So does anybody know who came along in 1913? Spice things up? Bohr, yes. Niels Bohr, Danish guy. He came up with his model of the atom, where electrons could only inhabit specific shells around the nucleus. So it would have a different energy depending on what shell it was in, and when it jumped from one shell to another, it would release light at a frequency that corresponds to the energy drop. Given the radius of these shells, you could figure out what those energy drops were, and it turns out you can derive the Rydberg formula based on this model. And as soon as people got a hold of this, they were like, oh, you just came up with a model that explains this thing that we haven't understood for so long. What does that mean, right? So all these people got a hold of this model and a couple other ones that were invented in the early 1900s, and they came up with quantum mechanics, which is a theory that gave us the electron microscope and the cyclotron and the laser and the transistor. I'm sorry, I need to take a deep breath. I get a little overstimulated when I think about how cool science is. It's just so cool. Sorry. My point is, theories are useful. They're not just interesting to think about. They're useful things that we need. They allow us to share understanding because without a theory, you have to memorize every single experimental result in your field to understand the breadth of knowledge there. If you have a theory, you can tell someone else that theory, and then the experiments sort of fall into place or they don't fall into place. So they're a really great communication tool, and they also point us toward directions to move to try to figure out what else can be done with our system. And DevOps is a system, right? So DevOps is composed of a lot of interlocking pieces that sort of we hear about on blogs and in conferences, but we haven't done a lot of thought to figure out how they fit together or where they come from. So a DevOps theory, if we were going to come up with a theory to describe this system, we would need to describe all sorts of things. We've got breaking down silos, continuous integration. People like to talk about empathy, measuring everything, chatops, like all these things that seem kind of maybe related, and they all fall under this umbrella of DevOps in a nebulous sort of way. But what do they have in common? I would argue what they have in common is that they are ways to improve your organization's communication. And when your organization has better communication, it has better product. Which brings me to the main thrust of my talk here. There was a law written in 1968 by Mel Conway. And this is a picture of Mel Conway. This is a link to the paper. The paper is short and very readable and still relevant in 2014, even though it was written in 1968. So I highly recommend reading it. It sort of goes to show that like you can't possibly hope to learn all the DevOps tools and all the programming languages that come out in a given year. But if you learn a little bit of theory, it will last you many conferences into the future. Also, I think we need to thank Mel Conway for becoming a programmer rather than a Hollywood actor, because he clearly had the face for it. So Conway's law goes like this. If your organization designs a system, then it will produce a system that mirrors the communication structure of your organization. I think this is kind of intuitive for a lot of people, but it's good to see it written down in sort of a formal way, and the paper is excellent. He states it another way later in the paper, saying that if you're not completely flexible with the way your organization communicates, then every time you make a new product, you're just going to make a photocopy of your org chart, and that's the new design of the product. This is easy to believe if you think about the bigger organizations that you've worked in or the smaller organizations that you've worked in. And Eric S. Raymond, the noted programmer slash software advocate slash libertarian gun nut, puts it very pithily to say that if you have 4 groups working on a compiler, you get a 4-pass compiler. Right? Because everybody wants to build an artifact, hand it off to the next person. They build an artifact, they hand it off to the next person, and so on. So, you know, we get this, right? And Conway offers a proof of it in his paper, but it's sort of a social theory sort of thing. So even he puts quotes around the word proof, right? Like, it's more of a plausibility argument. But I like it. It goes like this. Imagine some system, and imagine the organization that designed that system. Each of arbitrary complexity, no matter how big or small you want to imagine them, right? We can draw a diagram of the system. This is, like, we see diagrams like this on whiteboards all the time. It's every circle represents a node, a subsystem, a component of the system, and every line between circles represents an interface between those two subsystems. We do this all the time, right? So for any given piece of the system, we can identify the team that designed that piece of the system. And we can draw them over here on the org chart, right? We can do that for every node in the system. Every piece of the system was designed by some team or some person. And then we can also look at the connections between nodes and say, well, this connection represents an interface between 2 pieces of the system. So at some point there was negotiation, probably throughout the whole design process, between the 2 teams that designed these pieces of the system. They had to decide how much traffic could flow over this interface, what the format had to be, what it was going to be made of. All these sorts of things had to be communicated and negotiated out. So there must be a line between those 2 pieces of the team in the org chart. And the same is true for every line on the system. Now, how do we know that there's not another line in the organizational communication structure that doesn't exist in the system? Well, there could be, I guess. But Conway puts it sort of cynically and says that we are really in love with our own designs. If I make a design, I'm going to think it's the best thing in the world, and I'm definitely not going to change it if I don't have to, right? If somebody comes in and says, my piece needs to talk to your piece, sure, I'll change it. But if somebody comes in and says, hey, I work 3 floors above you, I've never met you before, but you're doing it wrong, I'm going to kick him out of my office. So that's sort of the gist of his plausibility argument. It's a little hand-wavy, but it makes intuitive sense. And now we have an organization that has a communication structure that mirrors its design, and they want to design a new system. Well, how are they going to design it? Well, we've got these 2 teams over here, and they know each other, right? They know how to work together. They have process. So why don't we build a system that has those 2 pieces that connect to each other, right? And we'll put new modules in them. It'll be new and shiny, but you know, we know how to work together, right? And of course, everybody went to Ruth's kid's bar mitzvah, and she's on the middle team, so everybody knows Ruth. Let's work with Ruth. Ruth's great. But we don't know any of the people on the right-hand side, on the left-hand side, right? They've never met each other. They don't know how each other's products work. So why don't we just have the middle team broker the communication between those two pieces of the product? Well, what do you know? We ended up stamping out our org chart onto a new design. And this is a problem, right? So Adam Jacob of Chef puts it that your organizational structure, you think it's a solution to your problem, that you couldn't be solving your problem with a different organizational structure, but really it's just left over from the last time you solved the problem, right? Any engineer knows that there are multiple solutions to any given problem, infinite solutions to any given problem, and you choose one based on your time constraints and your staffing constraints and whatever other constraints you're under. There's no one right solution to the problem. So how can there be one right org chart for a company that builds a system? So there's actually a really interesting study that came out in 1990 about this, where they were looking at a couple generations of camera companies, and they found that the market leader, anytime there's an architectural innovation in camera design, where it's not just new components, but in fact the components talk to each other in a new and better way, the market leader flounders, falls apart sometimes. And they examined the organizational chart of the market leader and found, well, yeah, they have an org chart where there's the team that works on this system, and they know the team that works on this system, and now those systems don't talk to each other, or now these new systems do, and they were unable to keep up with the change in the system design that they needed to keep up with. So DevOps, right? Well, we're, in modern web product design, we're constantly redesigning our systems. You know, if we're doing continuous integration, we're changing it every day, and the stimuli to which our systems are responding are changing every day too. Different load profiles, different features that people want. So if our product is changing every day, we need our really flexible communication structure so that we can not stagnate and keep the same product design over time. So we can, if we have a theory that describes DevOps, we can start to try to apply it to the individual pieces, right? So we got chatops. Everybody likes to get in the chat room together and do their deploys and blah, 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 blah. Why does this work? Well, so we have a system that matches our organization and vice versa. When a new dependency gets introduced to our system and breaks one part of it, we have to know about that right away, so that we can. So there's a team that's responsible for that system, and they're like, oh God, why'd it break? They don't know. They didn't see the change log, right? So they have to know, who do I talk to about this? What's wrong? Like, as fast as possible, right? Because we want to minimize the time that our org chart doesn't match our system. And so when you're doing all your communication by email or through people's bosses, this takes a long time. But when you have a chat room, somebody says, hey, I changed a thing and it broke this other thing, and somebody can be like, oh, I'm responsible for that thing. Why don't we talk in the chat? It's all right there. It allows you to be almost infinitely flexible in what part of the organization you're communicating with, because they're all right there in the chat. And it allows you to put your organization back in sync with your product and fix the thing. We've got infrastructure as code, right? That's another DevOps thing. Everybody's into all this stuff, this Chef stuff and this Ansible stuff and this Puppet stuff. Well, so before we had infrastructure as code, right? This is the problem that DevOps was originally supposed to solve. Is like we have this wall of confusion between development and operations, and you know, developers are all like, Ruby, and operations are like, get out of my server, I'm running bash scripts, and so they're not speaking the same. They're not speaking about the same things, right? Sysadmins are more concerned about what's going on the Linux level and all these you know, device drivers and software that's installed on the machine, and developers are concerned with what I don't really know. I'm in ops. But the point is, when you do infrastructure as code, now you're using a common language that facilitates communication among developers, between developers and operations, right? when they couldn't communicate, you ended up with a brittle interface between software and platform because the org chart had a brittle link between sysadmins and developers. Now, they can both talk about chef recipes. Chef recipes, abstract away the operating system details and leave you with code that both of your teams can understand and talk about. So it lets you repair your organizational communication structure to match the thing you're trying to do. So my conceit here is that, wow, I'm really running under time. My conceit here is that DevOps is a special case of Conway's law, and it's useful because it allows us to keep our communication structure as flexible as our systems usually end up being these days. So I would love it if you just all agreed with me. That'd be great, but I'm not done. Hold on. Because what would be even better is if you came up with a better idea. Theory is a conversation, right? I don't necessarily want everybody to be like, okay, we're done. I want to be this theory, right? The theory that sort of describes your system, and then somebody comes up with a better theory that describes it better, and then somebody comes up with an even better theory than that, and eventually you're able to do things that you never would have thought of if you didn't have a good theory. So this is where I think we should start. Thank you for listening. Questions?
Is this on? We'll take questions. We'll run the mic, and there's also a mic, I believe, on a stand on the upper level. If someone wants to go to that mic and ask a question.
I really hope there's some questions because they've got like 9 minutes left.
So I've got one right over here.
Oh yeah. All right. Go ahead.
This isn't a question. This is a better theory. So, thing I've observed is business pushes development to change systems. Development's job is to change. Operations' job is to resist change, and that's part of the org chart too. You can bring that into the Conway's law theory.
Yep, that's a good point. That's sort of the. So back on this slide, are my slides still up there? Yeah. So back on this slide, when I had these two things that I replaced with Ruby, and hash bang bin bash, those blobs initially said, I want to make features and I want to be stable, right? That's what people think about when they think of the old model of systems and operations. But once you get them speaking the same language, they tend to agree more that really what they want is the same thing, they're just thinking about it in different ways. And developers don't want to write software that breaks all the time. They want stable software too. That's just not necessarily their first thought when it comes to the thing. Who else has got questions?
Yeah.
Yes, good questions.
All right, one more right here.
I think Conway's law said matches communication structure, and you kept saying org chart.
Yeah, I meant communication structure. I'm sorry.
Yeah, I guess my question is, in the paper, does he recognize that there's formal org charts and that oftentimes mirrors the true power structures and communication structures, but not always? Can you point that out or not?
He does go into a little bit about, I thought I didn't have time for this in my talk, but he does go into a little bit about how his idea shows why two people working for a year don't produce a better product than 180 people working for a week. If I did that multiplication wrong, but you can't just multiply the number of man hours times the number of people you have, because you end up, if you have more people, you end up with a different organization. You need to have people who have bosses and probably people who have bosses who have bosses. And you end up with a different system design because you're communicating through those bosses. You're communicating more slowly across organizations, and you have more communication overhead when you're going through all these buses. So that does sort of come up. Thanks for asking.
So Conway's law is about communication patterns and over here, if you're looking
hi,
for yeah,
hey.
hey,
Oh, yeah, James. how are you?
organizational structures and communication patterns. A lot of that is sort of veiled sociology. Have you looked at like sociological theories on how humans talk to each other and interact, and how that applies to this?
No, I would love to. That's a thing that I'm hoping to learn a lot more about in the next year. I think I did read a couple academic papers about, they were mostly in the product design space about this stuff. And there were a few experiments that people actually, I guess you could call them sociological experiments, where people actually looked at made a matrix of which functions in a given piece of software you have to change if you make a change to a given function. It's sort of a measure of complexity. If I change this function, how many other files do I have to change, right? It's a measure of coupledness. And they found that the less tightly coupled organizations, like open source projects, had clearly a less tightly coupled architecture if you took this metric than, say, a large organization that made a similar product to the open source version. So you can do these things experimentally, and I didn't go into a lot of papers, but they're out there if you want to read them, sort of empirically verifying pieces of Conway's law. Yeah.
Hey, how's it going?
Hi.
First of all, great presentation. I really enjoyed it.
Thanks.
I got 2 questions quick. Is this the same Conway who did the Conway's Game of Life theory?
I believe so, yes.
Nice, with like the cubes that walk
Yeah,
all
he was a
over the
badass.
place?
He is a badass.
Yeah,
He's still alive.
that's really cool.
Yeah.
The other one on a
Sorry,
more
Mel
serious
Conway, if you're
note.
listening. I know you're still alive.
On a more serious note, can you point me toward a really good website for finding killer GIF images?
They're all in my Imager personal account, and I haven't made them public because I like to hoard my GIFs, because I like to be the one in the company who has all the killer GIFs. So no, those are closed source, sorry. All right.
Got one more back there.
Oh, yeah, hey, sweet.
Come here.
Run.
This is as fast as I go.
Rather than requiring different departments learn a common language, wouldn't it be easier to reorganize the structure so that there's smaller teams with components of those various departments within that team? Right, for example, this slide, Ruby versus bin bash, your solution is that everybody learns the common XML or whatever that is underlying Puppet or Chef. Isn't that just adding a whole lot of complexity and learning to something that's getting away from somebody's primary job?
Well, that's a good question. So the question, I guess, is why should you have to? Well, I'm going to state it in a way that's probably going to misrepresent you, but why should you have to learn something? Why should both people have to learn something new when they both do their jobs fine already? Is that what you're saying? This is, I think you may be getting at a thing that Jeff Susno was telling me about last night at the bar, where somebody, I think Adrian Cockcroft had an article recently or retweeted an article about actually adjusting your product or changing your product so that your organization mirrors the product, right? If you change your product in such a way that it gives you the organizational structure that you want, you can sort of reverse engineer Conway's law or play it backwards. But I think that it's worth learning a common language or learning how to communicate with people on other teams in this way, because software and platform tend to be pretty tightly coupled no matter how much you wish that they weren't. And if you, what was I going to say? If you learn so you can't be a good engineer if you are bad at communicating, right? I think a good engineer is a good programmer, yes, but also you can be a good programmer without being a good communicator. And they're both really important to being an engineer. So any tool that gives me the ability to communicate better with the people that I work with, I think is going to be worth learning for me.
I just wanted to say they're different Conways. Melvin Conway, John Conway, Game of Life.
Oh, damn it. Sorry. Never mind. Mel Conway sucks. All right. Thanks a lot.
Thank you.